Hello friends, how are you? I hope you all are well. Today in this video I am going to explain some numerical problems which is continuation of the topic electric charges and field. So in my previous video I explained regarding the electrostatics, electrification, Coulomb's law and charge density also. Here are some numerical problems which is very important from your board point of view. I hope that you might have subscribed. If you have not done, don't delay. At the same time, don't forget to share these videos to your friends. Without delay, I am going to start. First question is, two identical conducting spheres P and S with a charge Q on each repel each other with a force F. That means, so this is the solution of question number 1. Two identical conducting spheres. Suppose this P is a sphere and S is a sphere with charge Q. Here is the charge Q, here is also charge Q. On each repel each other with a force F. So definitely, since these are two equal charges, like charges, definitely they will repel each other. The repulsion force is F. A third identical charged conducting sphere R. A third identical uncharged conducting sphere. This is third sphere, which is identical sphere, but it has no charge. Is successively brought in contact with two spheres. What is the new force of repulsion between P and S? The fact is that two spheres, identical spheres P and S, both having equal charges Q, and one more identical sphere, uncharged sphere, brought in contact with P and S. At first with P, thereafter with S. You have to calculate the new force of a repulsion between them. So in this case, if third identical uncharged conducting sphere is successfully brought in contact with the two spheres, what is the new force of repulsion between P and S? Now listen carefully. When the sphere R is brought in contact with the P, so definitely the charge on P will be distributed equally between R and P. So I can write after R in contact with P, charge on P, that is also equal to R will be equal to Q upon 2. That means the charge with P will be divided between P and R. Similarly, again next, charge on S. Charge on S after R in contact, the charge on S will be equal to, this charge is Q. Now this charge will be added and this one will be divided between S and R. Between S and R. So this is divided by 2. So I can say that 2Q plus Q upon 2 into 1 by 2. That means 3Q divided by 4. This is the charge on P. This is the charge on S. Now, what is the new force between them? Now, let us see the initial force. Initial force between P and S, that is F is equal to, according to Coulomb's law, 1 upon 4 pi epsilon naught Q square upon R square is the charge Q1. I have used the formula K Q1 Q2 divided by R square according to Coulomb's law. The new force between P and S, that means F dash is equal to 1 upon 4 pi epsilon naught. Now the charge here is Q by 2, so I can write Q by 2 into 3Q by 4 divided by R square, or I can say that this F upon F dash is equal to 1 upon 4 pi epsilon naught Q square divided by R square into or this is no need. I can write here 3 by 8 1 upon 4 pi epsilon naught Q square by R square. That means this is equal to 3 by 8 times of the original force. So this is the answer. The new force between the charged particle P and S, between the two charged body P and S, that is 3 by 8 times of the initial force. I hope that you understood. So I shall prefer to go to the second question. So you note it properly. Second question, question number 2. Question number 2. Compare the electrostatic and gravitational force between electron and the proton of a hydrogen atom. Just have to compare the electrostatic and gravitational force between the electron and proton of a hydrogen atom. Okay. So what is the mass of electron? Mass of electron equal to 9.1 into 10 to the power minus 31 kg. Mass of the proton is equal to 1.67 into 10 to the power minus 27 kg. And charge of electron, we know that 1.6 into 10 to the power minus 19 Coulomb. This is the charge of electron as well as charge of proton. Okay, so electron is negative, proton is positive, no doubt at all. Okay, so this is the mass, this is the mass of electron, mass of proton, and the gravitational constant 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay. So now we'll calculate the electrostatic force as well as gravitational force. So electrostatic force is equal to 1 upon 4 pi epsilon naught Q1 Q2. So Q1 Q2 means that is the charge of electron as well as charge of proton. So I can write the charge of electron as well as charge of proton divided by r square. Suppose the distance between them is r, so I taken according to Coulomb's law, electrostatic force 1 upon 4 pi epsilon naught q u q p, or I can say that both charges are equal, so I can write q square. Only we are taking the magnitude, so q square by r square. At the same time, the gravitational force is equal to g into mass of electron into mass of proton divided by distance between them. That means the distance between them is r square. So if I take the ratio between Fe to the Fg, it will be equal to 1 upon 4 pi epsilon naught q square by r square. So into r square g MEMP. Okay. So now I can write that 1 by 4 pi, otherwise you can write 1 by 4 pi epsilon naught. So here r square cancel. So 1 into 1 by g into q square divided by mass of electron into mass of proton. So this is equal to 9 into 10 to the power 9, the value of 1 by 4 pi epsilon naught into 1 by g means 1 by 6.67 into 10 to the power minus 11 into q square, that means 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 19 divided by mass of electron 9.1 into 10 to the power minus 31 into mass of proton 1.67 into 10 to the power minus 27. So if you calculate that, its value will be 2.3 into 10 to the power 39. Okay. So I hope that this problem you might have understood thoroughly. So you copy it. So now I am just rubbing it. We'll go to the third problem. So question number 3. Question number 3. 2 point charges 4q and q are situated a distance d apart. That means here is the 4q, here is the q. Somewhat up I will write a little better. So 2 point charges 4q and q are situated a distance d apart. That means this is 4q, this is the q. The distance between them is given d. Okay. Find the position of the third charge q. That means there is a third charge q, so that it will be in equilibrium. 2 point charges are there, 4q, q, and one third charge is the small q we have taken. You have to find the position of the third charge q so that it will be in equilibrium. So Q will be in equilibrium. So I can say that Q will be in equilibrium. It means the net force on charge Q will be 0. Now you see that both are the positive charges. Now QH we have taken another charge. It should be between any places, whether it may be here, it may be here. I have taken here and it is nearer to the Q because it will be in equilibrium. So here 4Q charge is more. Here single Q is there. That means the force exerted on Q will be less. That's why to counter it, to balance it, I have taken the small Q is nearer to Q than 4Q. Now the distance is given D. Suppose this distance from here to here is x. Here to here the distance is x. Now we have to find the position of the third charge. Now I have mentioned that the force on Q will be equal. That means I can say that if this force is F1, this force is F2, that means the F1 will be equal to F2, no doubt at all. Then what is this F1? Now you see this F1 is equal to 1 upon 4 pi epsilon naught 4Q into Q. 4Q into Q divided by x square. The distance between them is x. Similarly, suppose the force between small q and capital Q, that force is F2 is equal to, this is Q into Q divided by, okay, so this is according to Coulomb's law 1 upon 4 pi epsilon naught Q divided by, here to here the distance is d minus x square. So I hope you understood this force. I have used the Coulomb's law, k q1 q2 divided by r square. Here the distance is x, I have taken x square. Here to here distance will be d minus x, because the complete distance from here to here it is given d. So since it is x, so this is will be d minus x square. But I said that since the q will be in equilibrium, so the net force acting on it will be 0. That means F1 will be equal to F2. F1 will be equal to F2, implies that I can say that 1 upon 4 pi epsilon naught 4Q into Q x square is equal to 1 by 4 pi epsilon naught Q divided by d minus x square. So I think this one cancel. Now this 4Q, this is QQ. Okay, so this is also cancelled. So how much left? Implies that 4d minus x square is equal to x square. Implies that if I take square root in both sides, 2d minus x is equal to plus minus x. So now if I consider 2, so I hope that it is appearing or not. It is better I shall write here. See here. So now it is 2 of d minus x equal to plus minus x. Suppose 2 into d minus x is equal to plus x, implies that 2d minus 2x is equal to x, implies that 3x is equal to 2d, implies that this x equal to 2d by 3, x equal to 2d by 3. Otherwise, we can take that here 2 into d minus x, this is equal to minus x, implies that 2d minus x minus 2x is equal to minus x, implies that 2d is equal to x. That means it may be x equal to 2d or it may be x equal to 2d by 3. But in this case, x equal to 2d will not be acceptable. Why? If it is 2d, that means here, so both are the same charges. Their direction will be in one direction. So the net force acting on Q will not be equal to 0. So the answer is x equal to 2d by 3. At x equal to 2d by 3, the charge Q will be in equilibrium. So I hope that you understood this answer. So now I am rubbing it and moving to the next question. So question number 4. Question number 4. Find the relation between Coulomb and start Coulomb. Suppose 2 point charges are there. Their charges are Q and the distance between them is 1 meter. Now, here Coulomb is the SI unit, whereas the start Coulomb is the CGS unit of charge. So, I taken 2 point charges, both are charge Q, the distance between them 1 meter. So, in SI unit, in SI system, the Coulombic force between these 2 point charges, that one will be equal to 1 by 4 pi epsilon naught q square by r square Newton. Or I can write this is 9 into 10 to the power 9 q square upon r square. And in electrostatic unit CG system, I can say that this F dash is equal to, in this case, you consider 1 Coulomb is equal to x start Coulomb. 1 Coulomb is equal to x start Coulomb. So Q Coulomb is equal to x into Q. So x into Q, x into Q, Q1, Q2 divided by r square. Here is also r square. But in this case, I have taken this is the Newton. In this case, the R will be 100 R because this is 1 meter. Suppose this is R meter. This is 100 R centimeter. So I can take that this is in dyne. So I can write that x square q square upon 10 to the power 4 r square. In place of dyne, you can take 10 to the power minus 5 Newton, or this one will be equal to x square q square upon r square into 10 to the power minus 9 Newton. So in this case, now I can say that 9 into 10 to the power 9 q square upon r square is equal to x square q square upon r square into 10 to the power minus 9 Newton. So in this case, this q square cancel, r square cancel. What is left here? X square is equal to 9 into 10 to the power 9 divided by 10 to the power minus 9. It is 9 into 10 to the power 18, or implies that x is equal to 3 into 10 to the power 9. So this is the relationship between Coulomb and start Coulomb. I can write start Coulomb. The relation between SI and CGS unit of charge. Now I hope that you understood. So I am rubbing it and going to the next question or the last question of this video. See here. The last question is question number 5. A sphere of lead of mass 10 gram has net charge minus 4.8 into 10 to the power minus 19 Coulomb. That means say that Q is given minus 4.8 into 10 to the power minus 19 Coulomb. A sphere of lead of mass 10 gram has net charge minus 4.8 into 10 to the minus 19 Coulomb. Find the number of excess electrons on the sphere. So excess electrons means definitely it is negative charge, there is no doubt at all. We know that this Q, or I can write that this Q is equal to plus minus N into E. So in this case I can write that N is equal to Q upon E. So here is the charge is given minus 4.8 into 10 to the power minus 19 Coulomb, and the charge of electron minus 1.6 into 10 to the power minus 19 Coulomb. So this one cancel. So 1.6 4.83, that means the number of electrons excess, that is equal to 3. So I hope that you might have understood all these 5 problems. So in my next video I will try to bring some complicated problems related with the JEE and NEET. Until then, bye. Thank you.